The simulation almost fixes the problem. That is what makes the next frame worse. A lensing model spreads smoothly across the Boötes Void, while curved prediction lines calculate where the displaced filament should appear if hidden mass inside the region is bending background light correctly. For several seconds, the observed structure follows the projected path closely enough that the room settles down. Then the updated survey arrives. The filament drifts off the prediction map. The grid remains mathematically stable. The observation does not. One operator freezes the overlay. Another reruns the correction sequence. The mismatch survives both passes. Now the strongest explanation in the room has started increasing the uncertainty instead of reducing it. The comparison grid slips slightly out of alignment before anyone notices the thread itself. At first, it looks like a normal deep field update, a black region where almost nothing should exist at all. The Boötes Void spans roughly 330 million light-years, and most survey images treat it like background noise. Empty distance, stable darkness. Then the second frame finishes loading. A pale filament appears near the center of the void, thin, faint, almost transparent against the black. In the earlier frame, it sat slightly lower. Now it does not. The shift is small at first, but the grid no longer lines up cleanly around it. Nothing inside the void is supposed to move like this. Operators rerun the alignment process. The survey overlays stabilize. Neighboring reference points remain fixed exactly where they should be. The surrounding image holds steady. Only the filament appears displaced. If this were noise, it should vanish between frames instead of returning displaced. But the structure remains visible after correction, and now the displacement becomes easier to see. The correction pass was supposed to erase it. Instead, the anomaly survives the cleanup. For a few seconds, the image just stays there, a dark region larger than entire superclusters, with one faint thread still hanging inside it. Then the updated frame arrives again. The filament jumps slightly across black space. Not far, but far enough for the displacement to become unmistakable. Enough to make the empty region behave like something physical. The second image should have solved it. Instead, it makes the first one harder to dismiss. Older sky plates slide across the screen beside the newer survey frame. Different equipment, different observation periods, different calibration pipelines. The alignment markers pulse as the layers lock together around the Boötes Void. Then the pale structure appears again. Not dramatically, just the same thin scar suspended inside the dark region, sitting slightly away from where it appeared before. An operator shifts the overlays manually. The offset remains. For a moment, the room settles back into routine. Contrast adjusted, reference stars checked, edge distortion removed. The surrounding field stabilizes normally. Only the filament refuses to settle into one position. The scar remains fixed inside the void. Two survey layers blink back and forth across the monitor. One layer disappears, then the other. The faint thread remains between them, like something pressed into the image itself. The second survey reproduces the same displacement. That changes the pressure immediately. One bad data set is manageable. A calibration issue, a damaged sensor. But cross-checking is supposed to reduce uncertainty. Here, it does the opposite. Different records keep agreeing on the same wrongness. And now the earlier displacement stops looking like noise. It starts looking like behavior. A cleaner explanation finally arrives. The screen fills with a smooth simulation grid spread across the Boötes Void. Thin arcs curve through the darkness as the model traces how distant background light might bend around hidden mass inside the void. The ghost filament appears again. This time, the software pulls it into shape. A pale thread stretches along the simulated distortion path almost perfectly. The curve is subtle, but the fit is close enough that people stop arguing over corrupted data. Operators stop searching for corrupted data and start adjusting lens strength values instead. The movement no longer looks impossible, just misread. For a moment, the void makes sense. Even sparse matter across hundreds of millions of light years can distort light passing behind it. Distant structures can appear shifted from where they really are. The Boötes Void becomes a lens. The model recalculates. Smooth grid lines pull the filament sideways across the black field. The observed shape briefly locks into the predicted curve almost perfectly. Then the model pauses on a new overlay, because the explanation now creates a prediction. If hidden gravity bends the light, the ghost should continue following the lensing map as new positions are calculated. The distortion must stay consistent, predictable. And suddenly, the anomaly stops behaving like a visual artifact. The next frame can now prove the model right or break it completely. The lensing overlay settles across the image with precise stability. Curved prediction lines spread through the Boötes Void in smooth arcs. The simulated distortion field stays perfectly stable while the system tracks where the ghost filament should appear next if hidden gravity is bending the background light correctly. For several seconds, the prediction holds. Then the new frame arrives. The pale structure drifts sideways off the predicted path. Not far, but clearly enough that the prediction line misses it completely. The room does not react immediately. One operator freezes the overlay, another reruns the alignment. The model grid remains clean across the entire field, while the filament continues sitting outside the expected bend. The model stays clean, the observation does not. If lensing caused this, the structure should continue following the distortion map. Instead, the ghost shifts against it. The mismatch becomes impossible to smooth away. For a moment, the image becomes brutally clear. A perfect simulation spread across one of the largest empty regions near our cosmic neighborhood, and one faint scar refusing to stay inside it. The Boötes Void rejects the map. That changes the earlier explanation immediately. The clean fit from before no longer looks reassuring. It starts looking coincidental. And now the strongest explanation in the room has started increasing the uncertainty instead of reducing it. The original image returns one more time. No overlays now, no simulation curves, just the first survey frame sitting beside a short internal note pulled from an archived processing log. The text is plain, procedural, almost forgettable. Calibration uncertainty. The phrase is underlined once. For several seconds, the frame remains completely still. The Boötes Void remains stretched across the screen exactly the way it did before. Black space, sparse reference points, the same faint displacement near the center. Then the frame advances. The ghost structure shifts again. The label sounded routine, The behavior did not. If this were only calibration uncertainty, correction should have reduced the instability over time. Instead, every correction pass made the frame feel less reliable. The classification label no longer matches the behavior on the screen. Operators continue scrolling through earlier records. No one is searching for a single hidden object anymore. The pressure has changed direction. The stronger explanation still cannot explain why the void behaves like an active reference frame instead of passive background. The Boötes Void stops being background. That reframes the very first displacement retroactively. It no longer feels like the discovery of one strange structure hidden inside empty space. It feels like a warning that the emptiness itself was never stable to begin with. Astronomy measures everything against assumed stillness, distance, alignment, silence between objects. And here, across a region hundreds of millions of light years wide, the empty part of the map is the thing refusing to stay still. Empty space was never empty.